integration now.
Both?
Huh?
Both of them?
We'll do both today, I think. Yes. No. Ready?
Yeah.
Okay. Integration of proper partial fractions. Let's do the first one. So, if you can write A down. Yeah? Okay. So,
Minus 12 over 3x squared plus 8x plus 4.
So, we know what to do here. This is the two factors. You see, now we can't integrate this. You might think, oh, what about if I, make u equal this? Doesn't help. And maybe you think, what if I complete the square? Doesn't help. What we need to do is simplify it using the fractions. The clue, if you've got your calculator, let me show you. Not that calculator. Well, that'll do. The clue is if this has roots or it doesn't have roots. So if it has roots, it means it has factors, which means you can write it like this. Yeah. If it doesn't have roots, meaning it has no factors, then you have to complete the square. It's usually the way you can tell. So we know that this has factors, so that's why we can do it this way. Okay, let's try and get the factors. It'll have to be a 3x, an x. That's a 4?
Yeah.
2 and 2? Yeah, 2 and 2 and plus and plus. Like this. Yeah? And then we have an A here and a B here. Okay. Now, let me just I have a nice little trick. Do you have the first example I did on proper partial fractions in your notebook?
I brought
new notebook?
No, the note from the first one.
You brought the wrong book. Oh, wait a second. Let me just check something here. Of course. I forget now. How do you do this? I had a nice little trick. Oh my goodness. Let me check in Google for you. Maybe you've seen this trick before.
I think that I know. I think you make the same problem as the
Same problem.
like the problem, and then you integrate.
Yeah, no.
A value over factor and plus.
Yeah, no, but finding the A and the B. That's how you do it. Forgot. Now, there's a trick here. I don't usually use it. It's called the cover-up rule. We have two ways to find A and B. Do you remember? We can choose the X, or we can make the two equations. But there is a third way. But the reason I don't use this way is because it only works for simple problems like this. So this is a good tip for simple problems. And by simple I mean just like this. You've got just two of them. There's nothing strange, like there's no square, just simple one like this. What you do, let me just factorize this first. 3x plus 2, x plus 2. That's a bit messy, sorry. Okay, try again. 3x plus 2, x plus 2. Okay, so what you do, if you want the A, that A factor is 3x plus 2. So you go to this one and you delete this in your mind, and you make x equal to what you deleted, minus 2 over 3. So if you watch here, minus 12 over minus 3 over 2, 2 over 3, thank you, plus 2, minus 9. Let me just make sure there's something weird with the brackets. So this here is minus 9. And then you can do the same thing with the B. That's A is minus 9. You can cover this one up and then put minus 2 into this. So,
same like I said.
Is that what you're trying to say?
There is no difference between this and the way we do it. Just find the values of A and B.
Oh, that's what you meant.
Yeah.
Yeah, but I was trying to show you a different way to find them. Yeah. So we put in x is minus 2. So that's minus 6. Plus 2 is minus 4. Minus 12 over minus 4 is 3. Then we integrate. So I don't know, these are in the formula book.
Yeah.
This is minus 9 times 1 over 3 log 3x plus 2. And this one is 3 times log x plus 2. That goes into that 3 times. And you can bring the 3 up here to make it cubed. Too much? No. And then because of, you can bring this 3 up here to make it cubed. And because of the minus, you can change this into log. And because they're both cubed, x plus 2 over 3x plus 2 cubed plus c. This cover up rule is nice for simple problems. It doesn't work for, you know, the repeated ones when it's more difficult. At least I don't think it does. Works well for simple problems. Okay, so this is our first example. If you can write this down, then I'll do some more. Yes. You made it. And you have a jacket and everything. Didn't see mirror on your way in.
Do I have to simplify this much?
No. That was just the first example, Iad. We're doing another one now, so you can see it again. Okay, so next example. Yeah, we'll do B, if you can write that down. Okay. So what do they have on the top?
Minus 22 x plus 62 over.
Now, what I'm going to do is I'm going to factorize the bottom immediately. So I have 5x minus 6. Yeah. 5x minus 6. And then the other one is 9x plus 7. Now, we know from yesterday's lesson that you can write this as a over 5x minus 6 plus b over 9x plus 7. Yeah. But I was telling Musharif, we have a little trick to find the a and the b quickly, but it only works for simple problems like this. Okay, so what you do is, if you want the a, that's with the 5x minus 6, you cover 5x minus 6. So in your head, you delete this, and you're just left with this part. And then what you do, I can show you with the calculator. You use x, or you put x equal to 6 over 5, the value of this that you've just covered up. So minus 22 times 6 over 5 plus 62 over 9 times 6 over 5 plus 7. And this gives us the A. So it's a very quick way to get the A. A is 2. So, where's the pen gone? A is 2. And then likewise we can get the B. So what would I use for the B? Yeah, minus 7 over 9. So on the top, that's 7 over 9. And then on the bottom, it's 5 times 7 over... No, minus 7 over 9, isn't it? Because it's a plus. 5 times minus 7 over 9 minus 6. Because you're covering this one up now. So this time we'll get minus 8. Now, I don't usually use this method, but someone was showing it to me, and I think, oh yeah, it's a nice method, but it only works with simple problems, which is the reason I don't usually use it. But because these questions are a little bit longer, I'm trying to think of ways to do them a bit faster. You can change this into 2, integrate 1 over 5x minus 6, minus 8, integrate 1 over 9x plus 7. And the good news is, both of these are in your formula book. They're both in the formula book. You can look them up in the formula book, and you'll get 2 times 1 over 5 log 5x minus 6 minus 8 times 1 over 9 log 9x plus 7 plus c. If you want to clean that up a little bit, you can just say 2 over 5 log 5x minus 6 minus 8 over 9 log 9x plus 7 plus c. And that's another example done. So we'll move on to a more difficult one now that you've got the basic idea. Got this? Yep, okay. Let's not do C. Now I know C looks difficult, but I can do it very quickly again like the last one. So let's do D now. Or maybe even, hang on, let me have a look at the answers to.
Can we go now?
Yeah, no, I will. We'll do. Yeah, no, I'm going to do some more, don't worry. Don't worry. G? Yeah, G's a good one to do. G, if you can write that down, please. Yes.
What are we going to do with the same method?
Yes, because, let me write it down first. Right, what do we have on the top?
1 plus 2x squared
Yeah,
minus 1 plus 3x
yeah,
minus 37.
just like that.
Yeah.
I'm going to factorize the bottom immediately. So I have 4x plus 7. Yes, that's right, isn't it? Yeah. 2x minus 5. 7x minus 3. Integrate. Now again, from last week, we know that you can write this as a over 4, well, a number over 4x plus 7 plus a number over 2x minus 5 plus a number over 7x minus 3. And again, because this is simple, and by simple I mean all linears, no quadratics here, all linears, and no repeated roots, then we can use the cover-up method to get the answers quickly. So, let's do that. So first I cover up 4x minus 7. So that'd be 142 minus 7 over 4 squared minus 143 over... No, there has to be... I wonder if there's a smarter way to do this. If I type in minus 7 over 4 and then, yeah, equals, and then just type in answer, yeah. 142 answer squared minus 143 answer minus 37 all over 2 answer minus 5 7 answer minus 3 5 the first one. Now what do I use for the second one? So if I just type in, what's it, 5 over 2 equals, and then just go back, and the only thing I have to change now is this one will be 4, yeah, that's it, 4 answer plus 7, yeah, this is quicker, this is a 2, and then for the last one it's going to be 3 over 7, and if I go back, so I have to change the second one here. This would be 2 answer, yes, very good, 2 answer, okay, 2. So, nice and quick, we can get the ABC, and then we can integrate again, using the same rule as last time. So this would be 5 over 4 log 4x plus 7 plus 2, it will be 2 over 2, which will be 1, log 2x minus 5 plus 2 over 7, which we can cancel this here. And that's the answer. So you see, if you just looked at this, you wouldn't really maybe know what to do, because it's not clear from what I wrote how I got these, and here this is a rule. So just to make it clear, the rule I'm using in the formula book is this one. 1 over a log ax plus b. This is from semester 1. Okay, write this one down and then we'll do another one. Yes, I did see in the marking scheme before that it's okay. That's okay. Let's have a look. Let's do one that has a repeated root or something a bit peculiar. Like, yeah, I think I'll do H and I next, and then I'll let you try some. So I just wonder if this cover-up rule works for repeated roots. See, it works here for 2 linears, works for 3 linears. Might work for repeated roots too. No, it doesn't, because look, they did it the way I said. I showed you the first day by making equations, so it doesn't work for this. And this one doesn't work. Okay, yeah. So the cover-up rule, it only works for simple, non-repeated linear factors. You got that, Ms. Sharif, what I said yet? Okay, so what did I say? We'll do H and I. So if you can write H down. Let's see what this cubic has. Yep. Okay. What was the top?
16x squared.
Yep. Plus 18 like this. Okay, and I'm going to go immediately into the factors here. That's 7x plus 2, 2x plus 1, and you'll notice that there's only 2, but there should be 3. So one of the factors is repeated. We're trying to get a 2 at the back or 28 at the front. So it has to be this one, squared. Okay. We know that we can write this as a, or number, over 7x plus 2 plus number over 2x plus 1 plus number over 2x plus 1 squared. Now, maybe we can use the cover-up rule here, but we have to do a little bit of simplifying before we can use it. So what we'll do is we'll change this, because we need to make these. Remember I said cover-up only works for linear, non-repeated. Linear, non-repeated. And what's the problem here? There's a repeated one. But you can do a little trick to fix that. You could take the 1 over, you could take the 2x plus 1 out from these two. So then you're left with b plus c over 2x plus 1. You know? But I feel like this is getting a little bit messy. So I won't use this method for these ones. I'll just do it the way we used to do them. But it's still ABC on the top. And you remember, you say this equals this, and then you multiply by the factors, yeah. And we'll end up with 16x squared plus 65x plus 18 equals a 2x plus 1 squared plus b 7x plus 2 2x plus 1 plus c 7x plus 2 when you do the multiplication. So what should I choose for x first? Minus 2 over 7, I think, yeah. Minus 2 over 7. So that will cancel these two, and I'll just be left with 16 minus 2 over 7 squared plus 65 times minus 2 over 7 plus 18. Oh dear. But then that has to be divided by 2 times minus 2 over 7 plus 1 squared. So that works out nicely as A equals 4. And now what about trying to get the B? I can't really get the B next. I can get the C next by using what? Yeah, minus a half. So if we put minus a half in, and then we need to divide it by 7x plus 2. 7x plus 2. I get 7 for C. And then finally, how can I get the B? 0. So I get 18 equals 1 times A plus 2B plus 2C. So 18 equals 20. Oh, interesting. It looks like B is going to be 0 here in this one. B is 0. So this is 4. This one is gone. And this one here is, what do we say, 7. This one we can integrate fine. It's in the formula book. But what about the next one? Any ideas on how to do that one? Any ideas? We did it. There is a method we have that we can use.
By U?
Yeah.
2x.
So you say let u equal 2x plus 1. du dx equals 2. That means dx equals du over 2. So this becomes 7 over u squared du over 2, which becomes 7 over 2 u minus 2 du, which becomes 7 over 2 u minus 1 over minus 1, which is minus 7 over 2u, which is minus 7 over 2x plus 1. So minus 7 over 2x plus 1 plus C is the answer at the end. Okay, this is a good one for the exam, because usually in the exam they give you problems that require 2 different integrations, like a log and a substitution, for example. So this would be more like an exam question. So if you can write that one down. Mm-hmm. Yep. Okay. I know, please. And you know what? We'll take that minus outside. What am I doing? Just one factor. Okay. Got that? Yes?
Yeah.
Okay. So, let's have a look. What do I have on the top? 6x squared. Yeah. Okay, now on the bottom, we just have the one factor, 3x plus 1. That's all we have. So we get the other factor, do you remember how? Long division. So we need to do 3x plus 1 divided into the cubic, which is 3x cubed plus 13x squared plus 28x. Plus 8. Yeah. Okay. Well, that has to be x squared, so that's 3x cubed plus x squared. That leaves me with 12x squared plus 28x plus 8. So this one has to be a 4x. That's 12x squared plus 4x, leaving me with 24x plus 8. So it has to finish with an 8. That will make 24x plus 8, which is the 0. So that is the second factor here. Definitely can't use our cover-up method because this is quadratic. So we have to do it the other way by saying 6x squared plus 15x plus 45 equals a x squared plus 4x. Now, sorry, let me just write down what I'm saying this will equal. This will be a over 3x plus 1 plus bx plus c over x squared plus 4x plus 8. So when I multiply, I get a x squared plus 4x plus 8 plus bx plus c times 3x plus 1. Right, firstly I should make x equal to minus 1 over 3. Yeah, so let's see what I get there. Mode 1, 6 minus 1 over 3 squared plus 15 times minus 1 over 3 plus 45, and that will cancel, so I have to divide by that one. Divided by minus 1 over 3 squared plus 4 times minus 1 over 3 plus 8. I get 6 for the a. Next, I'll make x equal to 0. So this part goes. I'm just left with c at the end here, because it'll be 1 times c. So I'll get 45, I'll just do it on the side here. I'll get 45 equals 8a plus c. So c is 45 minus 8 times 6 is 48, isn't it? So c is minus 3. And finally, to get the b, I'll just put x as 1. So more rough work on the side here. I'll get 6 plus 15, well, we'll do it in our head. 45 plus 15 is 60. plus 6 is 66. X is 1, so that'll be 8 plus 4 is 12 plus 1 is 13. 13a, so whatever 13 times 6 is, plus, this will be b plus c, which is b minus 3. And then this one here will be 3 plus 1 is 4. So if I just calculate this here, 66 minus 13 times 6 divided by 4. Interesting, it looks like I'll get 0 for the b here. So if I zoom out a bit, just this bit here is, sorry, it's a bit messy, but this bit here is like side work. I need to kind of box it off. That's on the side.
A and C.
Yeah, so this will equal minus integrate 6 over 3x plus 1 minus 3 over x 3 x squared plus 4x plus 8 dx, which equals integrate minus 6 over 3x plus 1 plus 3 over x squared plus 4x plus 8 dx. I put the minus in. Now, this one here, this one here, yeah, it will be 6 minus 6 over 3, so that's minus 2 log 3x plus 1. And what about this guy here? This integrate 1 over x squared plus 4x plus 8. Any ideas what to do here? Yeah. So this will be 3 integrate 1 over x plus 2 squared plus 4. And do you remember what to do next?
U equals
Yeah, u equals
x plus 4.
Over 2. We did this one on a separate worksheet. So when you clean this up a bit, you get du dx equals a half. So this becomes 3 integrate, dx is 2 du. So actually 2 makes this 6 du, because you get 2 du equals dx. And then in here, x plus 2 is 2u. So this will be 4u squared plus 4. So I can take the 4 out, and 1 over u squared plus 1, do you recognize that one? 1 over x squared plus 1 is a special rule.
How did you get 4x? 4u squared plus 4.
Well, 4 is 4. What's x plus 2? What's x plus 2?
2u.
Squared?
4 is
Yes. So this will be 3 over 2 tan inverse u.
1 over x plus 1 is 10.
Yeah. What's x? Tan inverse u, sorry, x plus 2 over 2 plus c. Okay, now this is like an exam question, but I should point out what they love to do in the exam is for these questions they love to put in limits as well, which I'm going to do just to make it a little bit harder. So we'll put in, we'll go from 0 to from 0 to 1. Yes?
Yeah.
Or something else? We'll just go 0 to 1. So if I put in 1 first, I'll get minus 2 log 4 plus 3 over 2 tan inverse 3 over 2. And then if I put in 0, I get minus 2 log 1 plus 3 over 2 tan inverse 1. Log 1 is 0, so you're left with minus 2 log 4 plus 3 over 2 tan inverse 3 over 2. Tan inverse of 1 is pi over 4. So this one here is pi over 4 times 3 over 2 is 3 pi over 8 is the final answer here. This, now, what you have in front of you is an exam question in section B. And often they want the answer left in this form. So I know it seems like a lot, but in the exam, I don't know, something like this. Yeah, it could be something like 8 marks, you know. And the question will be broken into 2 parts. Part 1 will be to find the ABC, and then part 2 will be to integrate it. You know what, maybe I'll just find an exam to show you. Let's look at the paper from 2014. Look.
Yeah.
I don't trust you. Look. Okay. Are you looking? So, let's see. In section A, it didn't come up. In section B, here it is. So you see part 1, they want you to find the A. Then part 2, they want you to find the B and the C. So this is proper or improper? So how do you find the A and the improper here? Do you remember what's the first step to do in improper? Yeah. So you can get the A that way. There are other ways, but you can get it that way. And then next you get the B and the C. And then next you integrate.
B and C or all of it?
The whole thing. Well,
Including A?
yeah, well the A is just going to be linear or constant, so
Yeah.
So let's see how many marks that gets you. 10 marks.
7.
10 marks.
4 left. Yeah.
10 marks. Yeah. So actually 8 was too little, too few. 10% of the exam, 10 marks for this one here. And then the second part, we haven't done it yet. So it's one of those questions where I like it because you get a lot of marks for it, and I like questions where you get a lot of marks, because with practice then you can get lots of marks quickly and easily. But there's a lot that you're doing here, and it's easy to get lost or get confused, you know. Okay, so in your workbook here, you'll probably find, you know, K, L, M, N. These are easy because they're all linear and not repeated. It gets more difficult towards the end, like the last 4. This would be more like what you get in the exam. So in my head, it's like at the start there's section A questions, but then towards the end they become section B questions. I'll just see if I can find you a section A question of it. maybe in 2015. Because I have seen them in Section 8. And the funny thing is, I think I saw it in the business exam actually when I think about it. Which of course
They
I don't
have
have.
integration.
Of course they do. They're business students. You seem surprised.
It's about the music.
There, look. Here you can see in A7 you get it. But this one here, it's just to find the A and the B. What would this equal? A over plus plus find the ABC. Not too bad, right? Yeah. Okay, so I'll let you try these for a few minutes. These are on every exam, either in A or B or both. So like if you take the business exam, they had it in A. I wonder if they had it in B as well. They didn't have it in B, but you could have it in A or B or both. Yeah. Since you're engineering students, I feel like it's very likely that they'll only give you a B version and not an A version of this question, because A is a little too easy, and you are engineering students, and you don't like easy.
And in the B they will give me the factor.
Yeah, there's no rule that says in the syllabus they must give you the factors, but I cannot think of an exam where they didn't. Every exam I think of, they did give you the factors. Do you know? So
even if it's repeated,
yeah.
if it's like not repeated, I mean like the cubic has one factor and you have to find them.
They usually give it to you. But like I said, there's no guarantee in life. They'll usually give it to you, but there's a chance that they won't. Small chance. So just hope for the best. Okay. It will. But maybe you get more marks, you know. Okay, I'll close this now.